Welcome to Unit 2, Introducing Systems of Linear Equations is 2.1. In this example, they want us to determine if each ordered pair is a solution to the given system. If so, you're going to type a Y in the answer box. If not, type N for no. So the first thing I'm going to start out is by numbering each equation a 1 and a 2. And we're going to work with the first ordered pair. So in equation 1, it says x plus y equal to negative 6. And I'm going to substitute in negative 2, negative 4. So negative 2 is the x. Negative 4 is the y. Negative 2 plus, and I put negative 4 in parentheses, does it result in negative 6? I'm short $2, I'm short another 4, I'm short 6, and it equaled negative 6. It worked for the first equation. Now we need to know, does it work for the second equation? So I'm going to go with equation 2. It says 3x minus y equal to negative 2. And again, I'm going to repeat by substitution. I'm going to plug in negative 2 and negative 4. So 3 times the parentheses negative 2 minus a minus 4. Does that result in negative 2? I put these in parentheses because of sign changes. So 3 and negative 2 multiplied to be negative 6. A minus means plus 4. I'm short $6, found 4, I'm short 2, it equaled negative 2. It worked for the first one and the second one, so this is a yes. Okay, we continue with the second ordered pair. They want us to test, again, equations 1 and 2. I'm going to start with equation 1. X plus y equal to negative 6. This is x and this is y, so 0 plus a negative 6. Does that equal negative 6? 0 negative 6 is negative 6. It worked for the first one. That's why I put a check mark. Now we need to see if it works in the second equation. So we're taking equation 2. 3x minus y equal to negative 2. And again, repeat the same situation. 3 times 0 minus a minus 6. Does that result in negative 2? This is 0. Negative, it makes it positive 6. Well, here, positive 6 cannot equal negative 2. It didn't work. That's why I put an X. So our answer here is no. Okay, we're going to continue with example 2 now. Okay, we're going to do the same thing we did in the last example. Number equations 1 and 2. Our order pairs are x, y's. So we're going to start with equation 1. 3x plus 2y equal to negative 8. We're going to plug in the negative 2 and negative 1. So again, put anything that's every number you're substituting in, put them in parentheses. The reason we do this is because in case of sign changes. So now we see 3 times negative 2 is negative 6. Positive 2 and negative 1 is negative 2. So we get negative 8 equals negative 8. It worked for the first one. We need to see if it works for the second equation. So we write our second equation, y equal to 2x minus 18. And then we're going to substitute in. So negative 1, 2 times a negative 2 minus an 18. Negative 1, does that result in? That's a negative 4 minus 18. Negative 1 does not equal negative 22, so it did not work. So our answer for this one is no. We continue with our second ordered pair. Again, start with equation 1. 3x plus 2y equal to negative 8. Use substitution. 3 times a 4 plus 2 times a 10. Does that result in negative 8? 3 times 4 is positive 12. Positive 2 and 10 is positive 20. 12 and 20 is 32, and 32 cannot equal 8. At this point, because the first time equation we did it did not work, you automatically put a no. We're going to move on to example 3 at this point. This example, we're doing the same thing we did, but it's asking us to determine which point or points are intersections of the two given equations. So what that means is we're going to do what we did on the first two examples, and substitute in all 3 to see which ones work and which ones do not. So this is equation 1, equation 2, and we're going to start with equation 1. X plus 2y equal to 4. We're going to substitute in the first ordered pair of x, y. negative 2 plus 2 times a 3. Does that result in a 4? Negative 2, positive 2 and 3 is positive 6. Positive 4 equals positive 4. It worked for the first equation. Now we need to check the second equation. Y equal to negative a half x plus 2. So again, the same ordered pairs. 3, does that result in negative a half of negative 2 plus 2? 3 comes down. Remember, a negative and a negative makes it positive. Half of the value of 2 is a positive 1 plus 2. 3 equal to 3. It works, so I can say negative 2, 3 is an order solution. Now we need to go again and try the next set. So we're going to go again with equation 1, x plus 2y equal to 4. We're going to plug in the next ordered pair, positive 4, 0. So 4 plus 2 times 0, does that equal in 4? 4 equaled 4, it worked for the first one. Does it work for the second one? So y equal to negative a half x plus 2. 0, negative a half of 4 plus 2. Half of a negative. Remember, negative and a positive is negative, so we know we are negative. Half of 4 is a positive 2. 0 equal to 0. It worked. So I want the second equation ordered points. Now we need to go to the third ordered points and see if that one works. Give me 1 second. Okay, so we're finishing the last ordered point. Here's our x, y. Substituting into our equation, x plus 2y equal to 4. So we have 3 plus 2 times half. Does that equal a 4? 2 times a half, or half of 2, is a 1. So 4 equaled 4. It worked for the first one. Now does it work for the second one? Again, same ordered points we're plugging in. Now this side is now the half value. And then it's asking us to do negative a half of 3 plus 2. So this gives us a positive a half on this side. Negative half of 3 is negative 3 halves plus 2. But remember, 2 is the same thing as saying 4 over 2, because 2 times 2 makes it a 4, and 4 divided by 2 gives us back to our 2. So here we see a half equaling negative 3 halves plus 4 halves is a half. It worked as well for that one, so all 3 are solutions to our problem.